Okay, so for this video, I'm going to kind of run through what we're kind of thinking about for the state contest for the electrical, for the diesel equipment contest. So just got a basic training board here with wires, and no, not everybody's going to have the same trainer available like this one, but I've had everybody send me some pictures so we can make this work with pretty much what everybody has available at their particular school. So they're going to have some detailed instructions of building a light circuit using these two 194 automotive bulbs here, and we're going to build it a couple of different ways and make some measurements, and then probably have them explain some things as to why they get the reading they get with the meter or whatnot. So the first step would tell them to come from our positive here down to a circuit protection device, so either fuse or circuit breaker depending on the board they have. I think everybody's is going to have a fuse available for it, so it's important we have the circuit protection, so if something gets hooked up wrong or whatnot. Then from the opposite side of our fuse here over to just a simple toggle switch, and they'll have a list for the proctor and to make sure that they have all these components available. So in this first circuit, we're going to put those two lights in series. So coming off of our control switch here, we're going to go to the inlet of our first light. Contestants should know that if something is in series, that has to go through one light to get to, oh sorry, here I'm in the wrong spot, our other light here. That makes that a series circuit once our ground is connected at the last point in the two lights and round back to our ground. So there would be points for following the directions, hooking those components up, and the two lights actually coming on, meaning we got a complete circuit. Now it's a little bit hard to tell with the lighting of this video, but those lights are about half as bright as what they should be because they're in series. So then the contestant would be told to set a DVOM up to measure a voltage drop across each one of those lights. So we've got our DVOM made to this trainer. They can have a hand, separate DVOM. It doesn't really matter if it's auto ranging or manual ranging like this one, but part of the points would be that they set it to the proper scale. So we were on DC voltage 20 volt, which would be the right setting for this particular meter on this circuit, because we're at 12.65, which all the trainers will be roughly a 12 volt system. Doesn't really matter on the exact voltage as long as they're kind of in that range. So they would also get points for connecting the meter leads properly into the meter. So we're in the proper volt here with our red lead. Our black lead always goes in the common port, so now we have the meter hooked correctly. There would be some points for installing it into the circuit properly to do a voltage drop across each bulb. So if we go to this first light, red lead there, black lead of course here. You can see that we're at 6.36 volts. Now, one thing I we could put in there as well that they should do to do any diagnosing is, first of all, check the source voltage. So that would be going from our red to our black bar here. And this particular trainer has the voltage readout here. Not all those are going to have that, but roughly half of our volts should be dropping across that light because it's in series. We're at 6.36. So this is a little harder with this board one-handed shooting a video, but if we move over to the second light, because the directions would tell them to do a voltage drop across each. So now we're at that bulb, 6.26. It won't be exact because you got a little bit of resistance in each connection, of course, but basically if you add those together, they get within 1/4 volt of our source voltage, which is 12.65. So that way they would have the voltage checked in series with those two lights. So at that point we could ask, just depends on, we'll play with it and see, but why do you read those two voltages across those lights? They could explain that when things are in series, they divide the voltage up between the resistances, so each light is a resistance. So since they're very similar amount of resistance because they're the same type of bulb, they basically divided the voltage in half. The lights are dimmer because they're only getting half the voltage that they're normally required to have, so therefore that makes it a series circuit. Okay, and of course on the old series circuit, a break anywhere, everything goes out. So if one bulb burns out, nothing works. It's kind of like the old Christmas tree lights. So that would be that part of it. We could throw in now, measure amperage on that circuit, the total amperage. That's important because if they don't know how to hook the leads, obviously they'll blow a fuse. So if we told them to check the amperage in this circuit, they should know that they're going to have to move this red lead over to the amps. They're going to have to set this to our 10 amp setting on here. To measure amperage, you have to make a break in the circuit somewhere. Doesn't really matter where, but basically you have to open the circuit. It's in series, so that's going to go out, obviously. Now this lead will come over, connect there. The other lead will come back to where we disconnected it, which was this port. We put that in. Our lights come back on. We are tying the leads in series with the circuit, so the meter becomes part of the circuit, and we see that we have 0.17 amps flowing through this circuit. So with those two bulbs in series, our amperage will be 0.17 amps. Okay. Now, we'll turn our meter back off, disconnect, return the circuit to normal, and then the contestant would be instructed from their directions to put those same two lights in parallel. So to do that, these two have to be in parallel. Each light gets its own ground, so it makes no difference if they connect that here or go down here to our bar. Either way. Now the lights are twice as bright as they were before because it's in parallel with those two lights. Once again, go back to measure the voltage drop across the two light bulbs. So we're moving our meter from the 10 amp back over to the volts where it should be. We're going to go back and select our 20-volt scale. Red lead of the meter to that side of the bulb, black lead of the meter to this other side of the bulb, and now we have 12.59, 12.63, so that bulb is now getting full voltage because it's in parallel. That's why the light's brighter, because it's got the right amount of voltage now. I want to skip this step, but I would move this contestant and then move these two leads over to the other light, and we get the same result, the same amount of voltage dropping across that light. So each bulb has its own voltage, it has its own ground, they don't share, so that puts it in parallel. That's our normal lighting system, and both lights are as bright as they should be. So that was the voltage drop in parallel. So back to checking the amperage with the same two bulbs in parallel. Same thing. We have to make sure we move our meter lead over to our amp port. Black stays in the common. Our meter gets set back to the 10 amp. Obviously, if they don't know how to connect the leads, it's going to blow a fuse and not work. So that's part of seeing if they know about the electrical circuit and how to use the equipment. Once again, we're going to go over to this side of the switch. It doesn't have to be here. It can be basically anywhere that it's in the series part. So it's going to get a different reading if you try to check it at each individual light. But if you get in the series part of the circuit before it branches off into parallel, you can do it on the positive or the ground side, either one. Amperage is the same throughout the circuit, so we're going to once again disconnect our circuit. Okay, I'm going to lay this over out of the way. Go to our 10 amp. Our common lead is going to come back to where we disconnected that to put this meter in series instead of the leads placed in parallel with the circuit. Now those same two light bulbs are pulling 0.51 amps. It's the same two lights, but with them in parallel, the total resistance of the circuit is less than it would be in series, because series the resistances add together. Parallel, they actually go down. It'll be less than any one resistor in the circuit has. So back to Ohm's law, if resistance is decreased, voltage is the same, amperage goes way up, and as you can see, we went from 0.17 to 0.50, so a half an amp. That's a considerable difference, and obviously the lights are a lot brighter. They've got full voltage across them, more amperage flowing, so I think that would pretty much wrap up the station, and they would get points for each thing, and the rubric will be laid out to where they get points for each thing, doing it properly, and it'll all total 100 points. So that's just the idea I had for doing it. Thanks.